All right, today we're going to talk about parallelograms, and parallelograms is a four-sided shape, so it is in the family of quadrilaterals, but it has some unique features of its own, one of which is, well, here they all are. We'll look at all of them. So when you're looking to memorize these, let's keep in mind that we have two properties that deal with the sides. Opposite sides are parallel and congruent. Two properties that deal with the angles. They are congruent, and consecutive angles are supplementary. And then diagonals bisect each other, and diagonals make two congruent triangles. So as far as memorizing, two deal with sides, two with angles, and two with diagonals. We're going to step through each one and see what we need to know and what those different properties will do for us as far as solving. Alright, so if we know that opposite sides are parallel, we want to also be familiar with how do we mark that. So parallel things are marked with either an arrow like that or maybe a triangle. And if you have two different parallel things in one picture, you would do a second marker. So match up the single markings are parallel and then the double markings are parallel. All right, and so in this case, what that does for us, it tells us that alternate interior angles are congruent, because when we have parallel lines and a transversal, we know these angles are alternate interior and they're congruent. So that would match up. 1 would be congruent to 4, and angle 2 would be congruent to angle 3. Let's see what that'll do for us. So here in this picture, we have missing angles. Well, I first of all know that if 30 is this angle, this would have to be 30 as well. It is alternate interior to that one, and this would be 45 because these are alternate interior. From there, I could keep going and I would say, well, this is a vertical angle. That's our prior knowledge. We know that vertical angles are congruent. And then from there, I could see that this is a linear pair. So this one must be 75 because they together need to equal 180. And if that one is 75, this one is 75. Okay. And from there I could find this missing angle because of triangle sum. So I've got 180 minus 105 and minus 30. So minus 135. So that would give us 45 here. If that one's 45, then this one's 45. And if, how do we get the other? Well, we can do triangle sum. We would also, well, yeah, we'll just do triangle sum. So we've got 180 minus 75 and 45. Okay, so that is 120. So that should leave 60 degrees here. And if that's 60, then this one is 60. All right, so that's how you would find all those missing angles. Here's the same idea. If this one, if the orange one's 45, this would also be alternate interior angles. And if that's 70, this one would be 70. And from there, I can use triangle sum to figure out x. So I would say 7x minus 5 plus 45 plus 70 would equal 180. That's how I would solve for x. Continue on solving, isolating the variable. And over here, I would say 5y plus 45 plus 70 would equal 180. And then continue that to solve for the variable. I'm not going to take time to do all the algebra right now, but you can do that solving for your variables. All right, the next property is that opposite sides are congruent. So across from each other, we have congruence. So we want to mark that congruent. Congruent is our markings. So what we would know here is these opposite sides are congruent. And what do we always do with congruent things? We can set them equal to each other. Okay. And I can solve that for x, and then I could find out the other side by substituting n for x. Okay, so I'll let you do the algebra. We also know that opposite angles are congruent. So these angles are going to equal each other and these will equal each other. So as far as solving here, I would know that 3x minus 2 should equal 73. That would be the equation I would set up for that. Solve that and you can find x. Fourth property is that consecutive angles are supplementary. So that means an angle and the one next to it should equal 180. These will equal 180, these ones, and these ones. So any angle and the one next to it. So when I've got consecutive angles and I need to solve, well, I know that these two, they're not equal to each other. They are going to add up to be 180. Consecutive angles are supplementary. Combine like terms and solve that. And then the fifth property is that diagonals bisect each other. So that means each half of a diagonal is congruent to the other half. And at this point, they're not congruent to each other. They're just congruent to the other half. The diagonals themselves are different lengths. And so, again, congruent things, I'm going to set them equal to each other. So solve for x with that equation. Set 8y plus 4 equal to 36 to solve for the other equation. And then the last one, we know that when there's a diagonal on a parallelogram, it's going to make two congruent triangles. Because I know that this side is opposite of this one is congruent. These opposite sides are congruent. This diagonal is congruent to itself. So right there, we're using side-side-side property to say those two triangles could be congruent. We also know this angle is congruent to this angle for alternate interior. This angle is congruent to this one for alternate interior. And then these angles across from each other are also congruent to each other. So then you could use any of the properties, angle, side, angle, side. You wouldn't use hypotenuse, leg because you don't know that this is a right triangle. Okay. Now, as far as how do we prove a parallelogram is a parallelogram, any of the properties on their own will prove it, but there's one unique one that will prove it, and that is number 5 here. Let's take a look at this. If we know that two sides are parallel and they're congruent, so the same side is congruent and parallel, we know it has to be a parallelogram because the only way to connect those congruent parallel sides is with another parallel congruent side. So this is not a property on its own, but it will prove the shape is a parallelogram. All right, so let's take a look. So we're going to ask ourselves, which one of these could we prove a parallelogram? So it's not this one because we don't know anything about those sides. So it would have to be this one, and we want to know the reason. Opposite sides are congruent. We want to know the reason why we're doing things. Okay. Which one of these? Well, this one, of course, has opposite angles are congruent. So opposite angles are congruent. This one does not have that. For this one, we don't know enough information about this one, but we do have diagonals that are congruent. So congruent diagonals. Diagonals that, I'm sorry, not congruent diagonals, diagonals that bisect each other makes two congruent bisected pieces. So this is the fact that diagonals bisect each other. How about this one? Again, here we only have one set of parallel lines and a different set of congruent sides. So we're going to go with this one. One side is both congruent and parallel. And so that would be a parallelogram. All right, and that's all for today. We'll talk to you later. Bye-bye.